structure of atom.
Sir, happy birthday.
Oh, thank you. How do you? I'm not going to discuss. Which is I'm not going to discuss with you. Is the preliminary portion where the discovery of electron, proton, and neutrons are mentioned, along with their properties, physical properties, masses, and charges, and everything. Because this you know it already. So things which require more discussion, I'm going to put more emphasis on it. So I'm not going to discuss anything about the electron, proton, and neutron discovery and their properties. So now assume that we know electron, protons, and neutrons, but we do not know where are they. Okay. So that is the situation which people faced after the discovery of protons. It is first the electron was discovered in 1895 or 96. And after that, people had a feeling that as the electron is having a negative charge, there should be another particle which should be positive in nature, having the same charge. Why? Because all substances are electrically neutral. And if the electrons are present in the atom, then there should also be a positively charged species. But somehow the experimental designs those days were very crude, and people are not able to find an experimental evidence about it. Theoretically, they had an idea, but experimental evidence they did not have it. And somehow, after around 10 to 12 years after that, they have got the presence of the protons by using a perforated cathode, and they have got it. And from there, they have experimentally found out all its properties. Then, after a long gap, they could discover the neutron. All right. So, initially, people did not have any, when they have talked about the atomic structures, then they did not take into consideration neutron. Okay. So, first structure of atom was being proposed by J.J. Structure of was proposed by J.J. Thomson. By a model which is known as plum pudding. Okay. Plum pudding. Anyway, I have not tasted this plum pudding. Pudding I have taken, but it's called plum pudding one. So many of you know how to make pudding. And there you can put some plum and you can make it. Okay. So in his model, he has considered atom to be a circular one, just like looks like a pudding cake. And in this case, he has assumed that electrons and the protons are being randomly arranged, so that the total charges of them are being neutralized, randomly arranged. But he had no experimental design. He could not prove it experimentally. He has thought it is like this because all atoms are electrically neutral and electrons and protons are being in a circular entity, and by which he has proposed this the structure of atom. But anyway, this model did not hold. People discarded it. So after that came the very famous experiment is called Rutherford's gold leaf experiment. This is called Rutherford So what he has done, he has taken a radioactive source, a radioactive beryllium. Beryllium is not radioactive, mind you, but some of his isotopes are found to be radioactive. And he has covered this one with a very thin, he has covered very thin gold foil. Okay, a very thin gold foil. He has put this is the gold foil. And the experiment was being covered with those days photography films were not there. So he has covered it with a paper coated with photosensitive materials. All right. So from there, the radiations, alpha particle, beta particle, gamma particle, all these particles, they came out. And alpha and beta are particles with alpha particles is the heaviest one, having a charge of +2 and a mass of 4. So it is having the highest kinetic energy. Beta particle are negatively charged particles. And the gamma is a electromagnetic radiation. But it is found that in case of beryllium, only the alpha particle come out, alpha particle. Okay. So this okay. Now see in this case, this alpha particles came out. Okay. Then after that it is found most of the alpha ray went undeviated, straight it, and some of them are slightly deflected. Some of them. This. And only few of them have come up. It is. What is the observation? Most of the alpha ray pass undeviated. Second, few rays got slightly deflected. And third, 1 out of 20,000 rays is recoiled back. This is the observation.
Pardon, sir?
1 out of 20,000 rays recoiled back. Recoil means which bounce back. Okay. So now, first of all, how do you know it? How do you know that? I'll make little modification. How do you know it? See here. As this thin plate is being coated with photosensitive materials, wherever the ray will go, it will strike immediately. You will find a bright light is there. So it was being observed on backside, and it will make a permanent mark there. A permanent mark will be there, just like you might have seen that when suddenly the TV transmission goes, so in the screen you'll find that black, these spots are coming. Okay, so same type of sensitive, photosensitive materials were being used. So they would do the counting and find out. Now see here. So this is the observation. Let us not by heart. These are observations. So what is the nature of alpha particle? Nature of alpha particle has a mass of 4 units. That is, has high kinetic energy. Why does it have high kinetic energy? Because we know kinetic energy is half mv square. See. Second, it is positively charged. Now, why most of the ray have went straight? Because there is nothing to obstruct them. It has a high kinetic energy and it has nothing to obstruct them. What does it mean? The most of the space inside the atom is empty. Most of the space in the atom is empty. Why few of them has deflected? That is, we know like charges repel. So when the positively charged particle has passed through a place where positive charge is there, so slight repulsion is taken. Okay, it is some slight repulsion is taken. And why 1 out of 20,000 has come back? Because those are the particles it has hit the place where positive charge is there. See, where positive charges are there, which went straight like this, they got deflected. And the one which went and hit this one, it has come back. See, 1 out of 20,000 means that place is very small place. Very small space is there in which not only the positive charge is there, that place is the heaviest one. Because of that, it could obstruct the alpha ray and send it back. So from there, first time people could understand that inside the atom, we have a very small space which contains positive charge. And it bears the entire mass of the atom. Entire mass of the atom. And rest of the space is empty. So that place is called nucleus. And the other empty space is called extranuclear space. So from there, it is in that place where the electrons are there. When you have studied about electron, there you have found electron has a negligible mass. Mass of the electron is 9.1 into 10 to the power, I think it is minus 31 kg. So mass of the electron is so less. Okay, so such mass cannot stop alpha particle. So it will treat it as if it is empty. So from there, the Rutherford has concluded that the inside the atom there is a small space which contains the positively charged particles or proton. An entire mass of the atom is restricted there. And the size of the nucleus is 10 to the power 5 times smaller than the size of the atom. And electrons are moving in a circular fashion around the nucleus. See, I'm going to send you the note. So all these Rutherford's observations that you study from there. Is it clear now? The Rutherford's model? Hello?
Yes, sir.
Yes. So I'm not
Yes.
to write, because if I write, then in that case, in the class, I can speak less. So I'm going to send you a post you the note. From there, you read it. And I've written it in simple possible language. Okay. So now, for time being, people have accepted this one because it is being scientifically proved. But after some time, people have found there is a major mistake is there in his model. What is the mistake? Because he assumed this is the nucleus and this is the orbit in which the electron is moving in a circular path. So any type of movement, energy has to be supplied. So in that case, if the electron starts spending its own energy, see, we know electron is moving in this direction. Huh? It is moving with a centrifugal force. And this is the place where the proton is there. So centrifugal force should be balanced by centripetal force so that the electron or any moving object can maintain its own orbit. Then what is the centripetal force? The centripetal force is the attraction of the proton to the nucleus. All right. Now, as the electron is moving gradually, its energy is going to deplete. It is going to finish. So when the energy is going to decrease by every turn it moves, but the attraction of the proton remains constant. So in this case, what is going to happen? Gradually, you will find this electron, when it starts losing its energy, it will come nearer and nearer to the orbit, and ultimately, when it loses total energy, it is going to fall inside the nucleus. So when it will fall inside the nucleus, it leads to the collapse of the electron. Let me tell you, but this experiment you don't do at home. See, in your plug, there are two holes are there. Three holes are there. One is for neutral, one is for positive, other is for negative. Suppose you take a wire and connect both the positive and negative. What happens? Immediately the light goes. We call it short circuit. So same thing is going to happen. A negatively charged particle is falling on the positive particle, and this will lead to the collapse of the atom. And it takes only 10 to the power minus 8 or 9 seconds to happen. So if it is like this, if the atom collapse, the entire universe will collapse, because everything is universe is made up of atoms. Moreover, when this electron is moving around it, it is giving out energy. You can observe this one. When you start walking, suppose you are feeling cold, you start walking. Do you not find after some time your body has become warm? Why? So as the energy is being spent, the energy is being radiated like this. So electrons, when it's continuously moving, energy is radiated. Okay. Now see, at these days you can measure it. What you can do? You put a photographic plate. When you put a photographic plate, and after some time when you develop it, you will find the entire portion of the photographic plate will be white, because you are not born in the age of the camera roll. Have you seen camera roll? People used to take by the manual cameras, where each and every photograph you have to take manually with a click. Have you seen those roll? Huh? You have not
Yes.
seen. So when we used to load this camera roll inside the camera, we used to do it in a dark room. Suppose by chance if the light is there, your entire the roll will be spoiled. We call it exposed. Totally it will be white. Why? Because it is a continuous process. So entire roll will be white. But when you have, this is called, when you do something, we call it spectrum. When you take the spectra of this one, it's very interestingly there. You'll find that some portion is white, some portions are dark. Okay? Dark. So this type of spectrum, we call it discontinuous spectrum. So when we have taken this one, this camera, just roll from here, we have found it is not a continuous spectrum. It is a discontinuous spectrum. That is, here this radiation is not coming continuously. It's coming after a small gap. So again, see, first one is that they have told this theoretically. That is, if the electron moves around his own orbit by spending its own energy, so as gradually the energy will be exhausted or depleted, the electron will approach nearer to the nucleus. Ultimately, it will collapse and fall into the nucleus, leading to the collapse of atom. This is a theoretical thing. Why? Because it did not happen. Second, when they measured the radiation of such movement, they found that here electron is not emitting its energy continuously but discontinuously. So ultimately what has happened? The Rutherford model is also being discarded. Rutherford model is discarded. Then after that came forward the Bohr and some of his friends to propose a new atomic model. So before that, I want to tell you something. In between, many things has happened, which has helped Bohr to proceed for his atomic. Now see, it is found that if a charged particle oscillates or moves or vibrates, then in that case, you'll find it emits some radiations. And interestingly, these radiations consist of two types of energies. One is the electrical energy, and second one is the magnetic energy. Okay, and these types of waves are be generated. This electrical wave is generated and magnetic wave is generated, and they both of them they occur simultaneously, and they are being found to be perpendicular to each other. And that type of radiation is called electromagnetic radiation. All definitions which I am explaining, it is there in the code. I am to save time. So these are the two axes. Okay. And these are 90, these two are 90 degree to each other. So when the electrical field is generated, this is the wave which is coming out in the electrical. Okay. And this is the magnetic field. This lies in this place. Like in this. So these are the this. So this is called electromagnetic electromagnetic radiation. Very interestingly. So there are two types of such wave can be generated. One is called the electromagnetic radiation, and second one is called material radiations. Okay, we call it material wave and electromagnetic wave. Now, what is a material wave? Material wave, suppose say by you are walking by the side of road, or you are sitting inside your room. So you found some people are walking, huh? Or suppose a vehicle has passed by the side of you. Sitting at home only, you can hear those sounds. But if your house is totally insulated by a thick wall, so those type of thing you will not feel it. Suppose a heavy vehicle has passed through it, you did not get the sound, but you will find somehow in the floor is shaking. So what happened? Material wave, when it passes, it requires a medium. A medium is required. It may be a liquid medium, it may be a solid medium, even it can pass through air also. And material wave can of different intensity. Some may be very loud, some may be very less. Some may be vigorous. Take the example of earthquake. It is a earthquake. Whatever that we are feeling, it is a material wave. Okay. So depending upon the intensity at the source, you will find the wave is going to propagate. So you will find that suppose a earthquake is being created around 300 kilometers away from your house, you can feel it. Why? Because the wave has propagated through the land. Take the example of tsunami. It propagates through water. All right. So material wave, and it can be of different magnitude. Its wavelength may vary. All right. But interestingly, you'll find electromagnetic radiations, whatever may be its wavelength, but its velocity is found to be same. Material wave has different velocities depending upon the object which has created it. Okay. So whatever the disturbance created in the air by movement of a train, same type of disturbances is not being created by a truck or a car. But you will find more disturbances being created by a aircraft or helicopter. So their velocity may be different. But in case of electromagnetic radiation does not require any medium to travel. It doesn't require any medium to travel. It may have different wavelength, but its velocity is always found to be same. That is we know it is the velocity is stable by the velocity of light, 3.0 into 10 to the power 8 meter second inverse. All right. So this is being created. Now it is found that this electromagnetic radiation this electromagnetic radiation can be this electromagnetic radiation, whatever you get, it can be of wave nature or it can be of particle nature. All these things happen after by the theory proposed by Rutherford. So some may be have particle nature and some may be of wave nature. All right. So let me tell something about this wave and all this thing. Let me tell you.
Excuse me, sir.
Yes.
Sir, can the electrons change the charge? Same electron can change the charge again and again.
No. Charge of electron can never change. Charge of electron, charge of proton, it is same. It is one charge of electron is 1.666 into 10 to the minus 19 coulomb. Charges never change. Okay. Velocity of electron may change, but sorry, the wavelength of electron may change, but velocity of the electron will not change. All right. Now,
Thank you,
let
sir.
us know something about the wave theory. Okay, now see. So this type of radiations move like this. So you call it wave. So what is a wavelength? See, wavelength is measured from here to here, or from here to here. So this one, this raised part is called crest, and the bottom portion which goes down is called trough. So the wavelength is the distance from one trough to another trough, or from one crest to the another crest, and it is being expressed in the unit of cycle or hertz. Now, why do you call it cycle? See here, suppose I have cut this portion with the help of a scissor, and I twist it. Moment I twist, see, it looks like a circle. This is nothing but cycle. Because of that, unit is called cycle. Initially, it was called cycle. Now we call it hertz. Okay. So now, depending upon their wavelength, if it is very large, in now these days you are not using radio. So in this radio, you find that transmissions are there. Some are called medium, some are called short. So this depends upon their wavelength. So depending, so any electromagnetic radiation can have different wavelength. It can be very large and it can be very small. Take the example, suppose you have gone for infrared. Infrared has a long wavelength. Okay, but if you go for ultraviolet light, it is short. Okay, in between what is there? In between you have visible light. Clear? Now second comes the frequency. What is frequency? It is defined as the so wavelength is really, you know that this is symbol of wavelength, lambda. It is defined as the number of waves which passes through a point in 1 second. In 1 second. It is denoted by this symbol nu. Wait, now see here. So say this is the point from which you are allowing the wavelength to pass through. All right. Say It is this. This. See here, look, these waves are small. So the more waves can pass through it, more waves can pass through this point in 1 second. Suppose say you have made a hole and you allow the hanky to pass through. So through that hole, many hanky will pass through in 1 second. But if you put a long cloth, you'll find it will take hardly 1 or 2 or 1 cloth can pass through it. So in that case, it depends upon, you'll find in case of this, the frequency is more. In case of this, the frequency is less. Okay. So let us assume that from from here, suppose this is the crest. So in 1 second, say up to this much it is crossed. 1 second. 1 second. Okay. So how many waves has passed through? See, from here to here. 1. Here to here, it is 2. Here to here, it is 3. Here to here, it is 4. Here to here, it is 5. All right. So his frequency is what? 5. In this case, see how many waves could pass through. So 1, 2, 3. Here only 1. So frequency is less. All right. Now see, this is the distance it has covered. This is the distance. All right. So distance covered per second is called what? It is called velocity. Okay. So distance covered per second is called velocity. And for electromagnetic radiation velocity, you don't put V, we put it as C. C is the velocity of an electromagnetic radiation. Okay. So now, what is the frequency? What is the symbol of frequency? Frequency is nu. Here I counted, I showed you it is 5. But symbol of frequency is what? Nu. Now, how much distance is has covered? See, this is one wavelength. This is another. This is another. So this is another. So distance covered is equal to what? Distance covered is, here you can say 5 into lambda, but let me write a general thing. We call it nu. See, this is, I have counted, but this is the mathematical expression. Nu is the frequency and lambda is the distance covered. So is it not equal to this? So can I not write that nu into lambda is equal to C? So therefore what? Nu is equal to what? C by lambda. See, you find a physics book, this is given. Most of the students are by hearty. Nu is equal to C by lambda. But this is the simplest expression. It says the frequency is the number of wave passes through a point in 1 second. So distance it has covered per second. In physics, we know it is velocity. So the symbol of velocity for electron radiation is C. We have counted, we have found what is, when you count the number of waves, that is nu, and each time it covers a distance of lambda. Okay, so we find the distance covered is equal to nu into lambda, but that is equal to c. So because of that, I written nu into lambda is equal to c. Therefore, nu is equal to p by lambda. See, initially, I told you at the beginning when we have discussed about the fundamental part, sorry, fundamental units. Fundamental units. What did I tell? How did you used to measure the distance from one place to another? See, it will be interesting to know. In Northeast, people had a habit of taking koi from prehistoric time. So those days, if anyone is to ask any elderly person from village that what is the distance, then he will tell, by the time you finish 10 kois, you will reach that place. Because they know how much time is required to chew one koi. In England, people measured the distance from one place to another, that how many footfall you will have. Footfall you will have. That if you take 20 feet, if you walk a distance of 20 feet, not the present one, by his feet length, you will reach that place. From there, the unit of feet has come, foot and feet has come. So same thing we find. The distance covered, if you think that the distance from here to here is what? Lambda. So this is the one person's foot length. So how many is put? 1, 2, 3, 4, 5 in 1 second. So this is the distance. So this is the symbol of the number of foot he has put forward. This is the one, the distance for each. So it is nu into lambda is equal to c. From there you got this equation. I have given you more weightage on this one because you are not supposed to. By heart it, you should know where from the concept has come that nu is equal to c by lambda. Okay. Now, one more term which is not given in your book is called intensity. Intensity. See here. Intensity. Intensity means how many types of similar wave you can have in a 1 centimeter cube of a place. That is called intensity. Suppose you want to buy sweets. If the sweet is big, he will put 1 or 2. If the size of the sweets are small, he can put layers after layers in it. So in that case, there will be more. So same in the case for the electromagnetic radiations also. If the wavelengths are small, you can put many, and if wavelength is less, you'll have if wavelengths are small, you can put many, and if wavelengths are big, you can put less. So that is called intensity. Intensity. So if you want to call a person from who is a bit far, obviously you raise your intensity, that is you make your voice louder. Okay, you might have seen that when we're using electricity, sometimes you will find the brightness of the light is increased, sometimes it is going down. Why? When the similar wave reaches at the same spot in many numbers, then you find the brightness increase. That is the intensity of the light is more. And if few reaches there, then it becomes dim. Sometimes you are not able to read also your book. Okay? Okay, now we'll come across a term also called wave number. It is the reciprocal of wavelength. So what will be this? So it is denoted by what? Put a bar on the top. No. Sorry, sir. It will put a bar on the top of. And what will be its unit? Unit will be centimeter inverse, because these days we calculate on the basis of SI unit. In SI unit, either you have to use centimeter or meter. So wavelength is expressed in centimeter, and wave number, yes, it is reciprocal of it, its unit will be centimeter inverse. All right. So let me come back to our that information I told given you, that the the electromagnetic radiation, whatever we have, it can be it can have two types of nature. One is the particle nature, and second one is called the wave nature. All right. So let us talk something about the particle. See, anything which comes like this is a particle nature, just like rain. Rain does not come like waterfall. Water falls continuously. Rain comes in drops. So they have their, it comes like this. Okay. So they come in drops. When this type of thing comes in the form of energy, it is a bundle of energy. That is called, we call it quantum. We call it. So now we are going to discuss about the quantum theory of radiations. Quantum theory of radiations. Quantum theory of radiations is being put forward by Max Planck. He's a very famous person from Germany. Okay. And throughout the world, if anyone wants to know, go for very high level study about this thing, people goes to Max Planck Institute in Germany. And his name is being commemorated in the structure of atom or quantum science with the help of a constant we call it Planck's constant. So Planck has given the first theory on the particle nature of the radiations. Okay. And later on, this was being modified by Einstein. So the main points are made. Yeah. Main points of quantum theory. A hot body emits radiation Now, radiant energy. Energy which is released through radiation is called radiant energy. That you know it. If in winter when you feel cold, why do you sit near a heater? So that is the energy which you get it from the hot coil of the heater. That is called the radiant energy. Not continuously, but discontinuously in the form of small energy, small packets of energy called quantum. The energy associated with each quantum is directly proportional to the frequency of radiation. Frequency of radiation, that is E is proportional to nu, or E is equal to H nu. H is a proportionality constant known as, see, I told you just now, Planck's constant. And is equal to 6.26 into 10 to the power minus 34 joule second. Is it right? না খাইছে না। Okay, third. The energy emitted or absorbed means what? Emitted, absorbed means what? You have put one iron rod into the fire. iron rod will become red. So it is absorbed. When you keep it outside, gradually it will get cooled, means what? The heat will be given out. So that is called emitted. By a body can be either one, means this is one quantum, or any whole number multiple, because it's particle now, you can count them, of h, that is 2h nu, 1 we have already written, 3h nu, 4h nu, and dot dot dot. It is thus energy absorbed or emitted equal to what? So if I write it, if I write this is E, equal to what? E is equal to N H nu. N is the number of the particles or quantum given out. It will be 1, 2, 3, 4. Okay. So here we can write N may be equal to 1, 2, 3, like this. Now see here again. E is equal to lambda, because we know now. But there I can write. Okay, I'll write it. N is equal to number of quantum of energy that you should know. Okay, I want that whatever little bit I know, you also should know. So it may be equal to 1, 2, 3, 4, 5. Now what is this? H is the Planck's constant. See, I'm not specialized in this portion. I've done specialization in organic, so because of that, my knowledge is a little bigger. Huh? So if you have any question, if I cannot answer you, I'll talk to my friends who are done specialization in this unit. Because if you go to the higher level, people gather specialization one part of one unit.
Sir, can't hear you, sir.
You can't hear me. Can you hear me now?
Yes, sir.
Okay. So I told you that I am not specialized in this topic. So whatever I have learned, I want that you also should learn. And if you have any further question, if you do not know, I can ask my friends who has specialized in this topic. Okay. So in science, if you go further and further, your knowledge goes to a certain specific zone where we go for more study. But anyway, I don't feel shy to tell my ignorance in some part of the concept. Because if you can confess, then only you can learn. Planck's constant is equal to what? 6.26 into 10 to the power minus 34 joules second. Now what is C there? C is equal to C is velocity of electromagnetic radiation. See, I told you the wavelength of electromagnetic radiation may differ, but velocity is always same. Is equal to what? Is equal to 3 into 10 to the power 8 meters second. And what is lambda?
Sir, can't hear you, sir.
Can you hear me now?
Sir, when
Hello?
when you go far, we can't hear you, sir.
Oh, acha. See, if I talk to you in this way, then how can I write? Okay?
Yes, sir.
Okay. Just me see. Now, can you hear me?
Yes, sir.
Acha, good. So, lambda is what? Lambda is the wavelength. So, this equation is important for your numerical problems. All right. And today I don't have any class in 12 class, so I'll continue a little bit more. Because we have started. See, generally I start teaching class 11 in the month of May or June. So we are already running short of 2 or 3 months. Right. So because of that, I'm taking now 3 days a week. Let's see. So Wednesday, I don't take any class 12 class. So in that case, I don't know whether you have any other tuitions at that time. I may extend it a little more. Have you written?
Yes, sir.
Okay. So I'll now write down what are the limitations of electromagnetic radiation theory. Limitations of electromagnetic okay, I'll write here. Wave theory, huh? Electromagnetic wave theory. All right. So now, what are the limitations? Okay, I'll write now. This sometime is being asked in your exam. Though electromagnetic wave theory successfully explain the properties of light What are the properties of light? Such as interference, that you are going to study in physics, okay? Interference, because physics will have a chapter called optics. Okay? Diffraction, but it fails to explain the following phenomena. What are those? Okay. First is called black body radiation. I'll explain everything. Then the photo electric effect. Third, the line spectrum of hydrogen atom. Okay. I have another one which I'm not going to write. In note it is there. It is general. I have written for entrance exam only. But anyway, forget these three. We are going to explain. This three could not be explained by the electromagnetic wave theory. So let us go one by one. Out of this one you have already seen. If not, you can try in your house, but you have to take permission from your mother. Okay, you have to take a iron rod, and you can do, if necessary, you can do in presence of your mother. You put this, put on the your LPG. Anyway, thing will not be spoiled, LPG stove will not be spoiled, and other end you hold it by anything which is non-conducting, or you can hold it by a thick layer of cloth and start heating it. So when you start heating this one, you will find that initially that iron rod will be dull red. Okay. Then it will be bright red. Then it will look orange. Then it will look yellow. Then it is white and ultimately blue. So in your house, you will not be able to go up to such temperature. You may go up to orange. To get the full phenomenon, then you have to go to a blacksmith's place. In blacksmith's place, you will find all these things you are going to observe it. Okay. So let me start with the black. So we'll now go for black body radiation. Black body radiation. All right. So what we have done? Suppose a fire is there. Okay. And you have put a iron. Okay. Black iron rod. Now I let me not write black here, because iron, it looks like black only. So you have heated it. So what you are going to get, observe first. it will be dull red. Then bright red. Then will be orange. Then it will be yellow. Then it will be white. And then it will be blue. Okay? This is when you heat. Okay. Now when you keep it outside, when it starts cooling, well, right now you are not heating. When you start cooling, blue will be white. White will turn into yellow. Then this will be orange. Then it will be bright red. And this will be dull red. And initially it was what? Black. Again you come to the original place. Okay. Now see here. What is our observation? So this is being observed by this was being observed by everyone. Every blacksmith they know. Now the question is, see, when you are heating means what? You are supplying energy. So more you heat, more energy will be supplied. More you heat, the more energy will be supplied. And if it is a similar type of energy, in that case what? Say suppose initially you supplied energy like this. Okay. After that you have supplied more energy. Then you have supplied more energy. Then you have supplied more energy. Then you have supplied more energy. Okay, like this. Now, say this wavelength belongs to visible zone. See, what is visible zone? These are visible zone. This wavelength have a specific color. Because of this, all the color you can see. Now, as because my source of heating is same, so I'm supposed to get the same wavelength. All right, in that case, what is going to happen? Same, if I add the same color more and more, the color will be more and more intense. Color will be more and more intense. That is, there should not be any change of color. All right. Moreover, if I mix all the color, then it is going to take another color. If I mix all of them, they are going to take another color. See, we know right from our childhood that rainbow has 7 colors. You have seen rainbows for hundreds of times, even at this age. Most of you are 16 to 17 years old. Hundreds of rainbows you have seen. Can you tell me frankly, have you seen all the 7 colors distinctly? Have
No,
you
sir.
seen them? All 7 colors you have seen? Violet, indigo, blue, red, sorry, green, Vivgian, no. So violet, indigo, then blue, then green, then yellow, orange, and red. All 7 of them could you identify in the rainbow? Or only few colors you could identify? Tell.
Only few, sir.
It is you do not identify all 7 colors. You can see only few colors which are brighter. Is it not? Huh? So many people are there. Nobody can speak or what? Hello? Hello? What happened? Can you hear me?
Yes, sir.
Yes,
Tell
sir.
me, could you identify all the 7 colors in
No,
the
sir.
rainbow?
No, sir.
No, sir.
That is, you have seen only few which are bright. Is it not? Hmm? But we know there are 7 colors out there. Why you could not identify? Why? Because one color has merged with the other color. So the color which are fade, you could not identify. That is, it is continuous. See, it is like this. It is like this. Okay. So if I put a paper on the top of it, then you will not identify that I have 4 fingers here. Okay. But if I keep it like this, you can identify there are 4 fingers there. Clear? So now see here. According to the electromagnetic wave theory, as because they are the source of energy, if this in the process of heating of the iron rod, if I would have sent more and more amount of the same wavelength, that is, its intensity would have been more. In that case, the entire process, the iron rod would have looked red. But only thing is that intensity of the red color would have been brighter and brighter. But we found it is not like this. Every time a different color could be observed, and that too also distinctly. So what does it mean? Here, the energy is being absorbed or released in bundles of energy. So in first case, if n is equal to 1 quantum, second case it has came to 2 quantum, 3 quantum, 4 quantum, 5 quantum, like this. So they are distinct. See, what is the difference between atta and rice? See, these are the grain of the rice. Okay. But when you take atta, can you identify this grain inside this atta? Can you identify? Can you separate? Hmm? It is continuous because of that. But here you can count all this rice here. So this is the first information is given to us, that in black body radiation, why this iron object is kept on changing the color, because here the energy is supplied in the form of particles. In the form of particles. Just like that, you are throwing stone. Suppose you want to pluck mango from a tree, so you are throwing stones. Every time the one stone is going. Next time you thought that I'll throw 2 stones together. You have thrown two stones. So this is called the particle theory. Okay, this is called the black body radiation. So black body radiation first given us the information that energy is being absorbed, or energy can be absorbed or radiated in the form of particles. And what is that bundle of energy called? We call it quantum. So it is the first experiment of quantum theory of radiations. Okay, so I'll take 15 more minutes. Please hold on. I'll do the next one. It's called photoelectric effect. Photoelectric effect. Okay. So now, let us not bring chemistry or physics. See here. Suppose there's one stone is there. Okay, it is lying there. Or you can say it is a marble. How many of you played marble? or all of you are from highly sophisticated family, never played marble in your life? Anyone who played marble?
Yes, sir.
When in my childhood, even the my classmates who were girls also, they also used to play with us in village. Okay, now see this marble you have to remove from this place. So what do you do in that case? You have to throw another marble, is it not? Huh? So when you aim another marble, this marble comes and hits, then this marble goes out. Okay? So let us replace it with a stone. This is a stone. And you want to remove the stone from there. Can you remove it by marble?
No, sir.
Can you
No, sir.
displace the stone by a marble?
No, sir.
Then what you have to do?
Use a big object or heavier.
Yes, that you have to take a stone. Okay. So if you take a stone, if that energy of the stone by which you have thrown, if it is less, then this will not move. Then you have to take a bigger stone. So you go on changing the sizes of the stone. Ultimately, you will find a stone which one has more energy to displace it. Okay. So now from big stone will come down to a small electron. Small electron. So now let me draw an atom. Okay. This is an atom. This is the nucleus. And this, you know, have little bit idea of electron that you have already studied in your school. So you are not that novice or illiterate, you know. So I'll take one atom like this. Okay. This is, oh, see here, electron is here and electrons are here also, here also. This is a small atom. These electrons are held on the orbit because of what? Because of attraction of the nucleus. So here in this case, the electron is so tightly held, if you wish to remove it, will not go. That we are going to discuss when you go to the periodic table. Everything will discuss. Now, here you have taken an electron. See here, electrons are here. Now see, these electrons are, this electron is far away from the nucleus. So its attraction is less. Okay, so electrons are being held on the shell by the attraction of electrons. So as the distance increases, the attraction decreases. Just like that, there are many pranks which you cannot do it at home because you are scared of your parents until you will get scolding. But you can do it outside when you are far from your house. Okay. Similarly, also in this type of large atoms, okay, if you heat it with a particle, this electron will now, moment you heat it with a particle, and if the energy of this particle matches with the energy of this electron, what will happen? It will remain here. It will come out. But if the energy is more, what will happen? In that case, this electron will start moving. Okay, so let me tell you my childhood experience. Suppose, say in the, when we went for playing, sometime we have end up with quarrel with very close friends also. So many of the close friends never used to tell this thing at home, but some were very, very close to their parents. They went and told, just such and such, he has uh, mm, abused me or pushed me in the ground, I fell down. So his parent will come and tell to my parents. Okay. So in that case, what will happen? My mother or father will get, my father is to very calm and quiet. My mother is to get angry. So when I come, I do not know that they are from their house. They came and complained to my mother. When I come home very happily. Then when I entered the room, then I found my mother is looking with to me in a different face which I'm not generally not familiar. Then I could sense some danger, some problem is there. I think it happens to you people also. Girls are very nice and fine. Boys are will have this experience. So immediately I stop at that place. I prefer not to advance nearer to my mother. Then I look at her appearance. Whether should I move forward or backward? Then suddenly I found one stick is also there in her hand. Then you Ted advise me, what should I do?
Run, sir.
Ah, yes, good boy. So I know it is not now safe to be inside the house. Now, see what boundary make a difference between house and outside the house? Can you tell me? In every house it is there. How to differentiate house and outside? Because even your veranda is also outside the house. So is there any line is there in your house which differentiate or boundary between house and outside? Did you find in your house any boundary is there? Huh? It is not there in your house. It is very much there in your house. See here. This is the door, the frame of the door. What do you call this portion of the door? We call it threshold. So here, when I found that my mother is angry, I come and stand here. I come out of the threshold because I know if she advances towards me very ferociously, then I'll fly. So when the energy of this particle is equal to the energy of the electron, what is the energy? Binding energy by which electron stays. It comes out. If the energy is further, it will move. That is called photoelectric effect. That is, the particles hit the valence shell of the certain atoms by which the electrons are ejected and moves away. That is called photoelectric effect. Okay. This is the one which we are going to now discuss. Photoelectric effect. So is it now clear? Anyone has any doubt on photoelectric effect? I'm going to write the definition, don't worry. But this is the one which is happening to us in every moment in our childhood. Everyone in our childhood. All right. So I'll write now. The phenomenon of ejection of electron I will write here. Yes, it means one or more. From the surface of a matter when light of suitable amplitude sorry not amplitude suitable frequencies suitable frequencies strikes on it. On it means what? Is surface. And is called perfect. So let me draw it now. Unnecessarily things should not be made complicated. See, when you talk to our friends, do you not use very simple language? Huh? So in that case, we'll also try to learn from here like this. See here. So this is the surface and the electron is here. Okay. So moment it strikes, it goes. So this is the what? This is the incident light. And here I will not write reflected light because light is not going, electron is going. Then what should I write here? We write here photo electron because electron is being ejected by the light. It's called photo electron. Okay, so I'll conclude here. Then tomorrow I'll discuss it in detail. Clear? Huh? So now my request to those who have joined late, try to get my previous videos. You can request Sir Somnath. He can again post it in the group, so you can read from there. And my note is also there in this there for first chapter, and the second chapter I shall post the note maybe after a few days. Otherwise, you will not read your textbook. So my need a point is make it a point. Please first read textbook. Is my always advice to every students. Okay, the people who have written that textbook, they have written as per your syllabus. So you have to follow. In my notes, there may be many things which is extra. This I have written for those who are interested. First, you know the thing in your textbook, and if you want to learn little more, some extra informations I have given. So initially, don't go for extra informations. First, you digest the thing. Then you go for extra. See, in childhood, your mother did not serve